Okay, so a few little comments here about the homework programming project. I guess you should have had a chance to see this up on CCLE by now, and please take a look at it. I apologize for there's multiple pages there, basically because we wanted to make sure that there wasn't any detail that was unclear. It may look like there's a lot of stuff there, but it actually just is clarifications on clarifications to make sure that there's no detail that's not totally nailed down. It doesn't turn into very much code, at least in my hands, and students in general do really, really well on this project, but it will give you a chance to see how you kind of fully implement a probabilistic modeling calculation in two slightly different ways with slightly different assumptions, and to show you how making things more sophisticated can actually boost your sensitivity quite a bit. So if people have had a chance to take a look, do you have any things that you're wondering about or questions that have come up so far just based upon an initial scan?
I have a question, but it's easier if I just show you.
Well, feel free to join me here at the board if you want to.
Well, if you could just bring up the project.
Bring up the project? Sure. Hold on one second.
Okay.
Fire away.
And then can you scroll down a little bit?
Sure. Sorry for the little Linux tour there. Which page do you want me to go to? The equations?
Yeah, it's about the basic variance. Okay,
Uh-huh.
The P observed given the data is equal to multiplying all of the states of
Right.
P observant.
So just to clarify the nomenclature here, here we're talking about the set of all observations, and when we add this little subscript I, we're talking about a specific observation that's represented basically by one line in your input file. So fire away with what you wanted to ask about that.
Yeah, why are we multiplying all of them together?
So let's turn that into a statement about the model assumptions. So when you see things being multiplied together, what does that make you think in terms of model assumptions? Exactly right. So basically what we're assuming here is that the individual observations are independent draws from some population distribution characterized by kind of a mix of what we talked about in the last class in terms of a population allele frequency for some SNP, and hidden inside this term here is basically the sequencing error process. And so we're basically assuming that each individual read is an independent draw from this distribution that's characterized by a mixture of population allele frequency versus sequencing error.
Yeah, it just seemed like we usually multiply variables, independent variables together, but this seemed like we were multiplying states.
Let me see if I understand you. So which thing here are you calling a state? Obs I?
Obs I, exactly.
Obs I is a variable. It's a random variable. It could have different possible values, right?
Yeah.
So maybe the one thing that's confusing is how we present in the input file format in terms of what we give you as input. So in a real mission, modeling mission like this, we'd be getting base calls off of the sequencing machine, right? And those would be letters, right? Here we've tried to simplify things by basically cutting right to the chase in terms of, it could be two alternate letters we're calling S and S prime, and we're just giving you these probabilities, which is basically means the whole model for sequencing error is you don't even have to worry about it. So this is given to you as numbers that you can just use. So the key point that I'm saying is that the observable for a given read, obs I, is a random variable with possible states, basically like S versus S prime. It's like this is what the sequencer thought it saw at that position in the read. But we've kind of boiled that down to simplify your job in this project by basically giving you these likelihoods for what was actually observed coming off the sequencing machine. Does that answer the question that you were wondering about?
Yeah.
Okay, that was a great question. Anything else that people have wondered about so far in hitting the project description?
It's more like making sure you get the right file or format. Is this supposed to compile in Visual Studio or export like within C++? Or does it matter at all?
Well, Sean can probably speak to that better than I can since he's going to be running the automated tests. But presumably this will be on some kind of fairly standard platform like Linux,
Yeah.
right? Where you're going to... We basically requested that you supply a make or makefile type script that would be able to compile if you're supplying source code that needs to be compiled. So is it C or C++ or?
C++.
Okay, yeah. So Sean, if you want to provide more details to people about what they should assume in terms of supplying a makefile or...
Yeah, I think so long as it compiles, it should be, so long as they have a makefile, it should compile fine, right?
Well, I mean, on a typical platform, like, you don't even have to tell it the rules for how to compile,
Yeah,
you know,
yeah.
a C file or a CXX file or whatever it is that is the suffix for C++. It has default rules that it just is going to use to build it.
Yeah.
The only issue that I could see is you're going to want to make sure that the standard math libraries and so on are being linked, right? Other questions? So Sean, if you feel that there's anything that needs to be clarified on that, go ahead and
Yeah.
post an announcement.
Okay.
Other things that people are wondering about? Okay, well, thank you for the question. That is helpful. Okay, so resuming where we left off there. Today we're going to work through some more in-class exercises that hopefully will help you really get a handle on our scoring models for the project. In particular, this whole idea of the advanced SNP scoring model. And also sort of the implicit issues of computational complexity that we're kind of hiding in our information graphs. I want to draw that out explicitly. I want to make one more comment that's sort of general advice about not just this class, but actual real-world modeling. This is not a problem just for students or even for that matter for professors or just about anybody who's trying to solve real-world problems. We make assumptions. We have to make assumptions, but oftentimes our assumptions are invisible to us, and we don't even realize we're making them, and we can go astray if we don't check our assumptions. So just to be very concrete about specific things that I've been seeing, I often see cases where people's answer indicates that they didn't fully read what the question was asking and ended up basically answering a somewhat different question. An example of this was on this basic SNP scoring question that we did last time. The question asked propose likelihood models, but some people assumed that this meant draw an information graph, which is maybe a natural assumption given that we had previously, in the previous question, been drawing information graphs. So I guess, the thing that I would try to draw out here is, the vocabulary of how we break down a field so that we have words to talk about all the different pieces that really, really, really matter. That is really core to being able to solve problems. So the vocabulary really matters. We've put some effort, to define terms like likelihood model, information graph, pretty carefully in this class, and definitely consider them to be sort of essential vocabulary. Really, really try to light those up. I mean, when a word goes by and it's one of our key words, imagine it turns red in front of your eyes and it's sort of like big red warning label. This is important. I also do try to pause, in presenting any question to ask whether there are any pieces of the question that you're wondering about. And oftentimes I just get silence. Whereas I can tell that, you're actually wondering or unsure what some of these words are actually asking you. So please ask. Check your assumptions, and this applies equally well to real life, not just to this class.